Okay, let's do chapter 7 test. All right, determine the, the exact value of sine of 75 degrees. So that could be thought of as the sine of, say 30 degrees plus 45 degrees, or vice versa. It could also be thought of sine of 150 divided by 2. Okay, so if I do this one, the sine of two angles added is the sine of the first, cosine of the second, and on the sine of two angles added, it's plus cosine of the first, sine of the second, and special angles, sine of 30 is 1/2. Cosine of 45 is 1 over the square root of 2, or square root of 2 over 2, plus cosine of 30 is square root of 3 over 2 times sine of 45, which is 1 over the square root of 2. So I have 1 over 2 square roots of 2 plus square root of 3 over 2 square roots of 2. So I could have 1 plus the square root of 3 over 2 square roots of 2. If I had used square root of 2 over 2 on these, I would have had square root of 2 plus square root of 2 times square root of 3, square root of 6 over 2 times 2, 4. So either of those answers would have been okay. And if we did this formula, the sine of a half an angle is plus or minus the square root of 1 minus the cosine of the angle, all divided by 2, and this would go over all of it. And if it's 75 and we're 75 we're looking for, sine at 75 is in the first quadrant, the sign would be positive. So we're going to use the positive answer. Because it's in the first quadrant. And the cosine of 150, that's not in the first quadrant. That's over here. And that's minus the square root of 3 over 2. So we get the square root of 1 minus a minus, which is plus the square root of 3 over 2 over 2. That could be simplified a few ways, but any of these answers is fine. Okay, if we're between minus pi over 2, minus 90, and plus 90, then, and the sign is negative, we have to be in the fourth quadrant, and the cosine of the fourth quadrant is positive. So when we do sine squared plus cosine squared equals 1, and subtract that from 1 and get 16/25 and do the square root, and we have to decide whether it's plus or minus. We're going to choose the plus value, and that's 4/5. Now, if we're doing something between that's positive in either the first or second quadrant, 0 to pi, and the cosine's positive, we have to be in the first quadrant, so the sine will be positive also. So when we square the cosine plus the sine squared equals 1, we subtract that from 1, and we get sine squared theta is 144 over 169, and so sine squared is either plus or minus 12 over 13, but if we're in the first quadrant, it's got to be 12/13. Cosine of two angles subtracted. It's the cosine of the first, cosine of the second, and if it's minus, it's plus. Sine of the first, sine of the second. Cosine of the first, 4/5. Cosine of the second, 5/13. Plus sine of the first times the sine of the second. So we get 20 minus 36, which is minus 16 over 65. Tangent of 2 theta is the tangent of the double angle formula for tangent is tangent 2 tangent theta over 1 minus tangent squared theta. And the tangent of theta is sine 12/13 divided by cosine, which is 5/13, which reduces to 12/5. So we got 2 times 12/5 over 1 minus 12/5 squared. That reduces to, let's see, 24 over 5 over, see, that's denominator is 25, so 25 minus 144. 25 minus 144 is minus 119 over 25. And so you invert and multiply, you get 25 over minus 119. And we get 5 goes into 25 and leaves 5 times 24 is 120 over minus 119. If I didn't make arithmetic errors there, I should check my key and make sure that's what I had. Yep. Now you could have done this as the sine of 2 theta, which is 2 sine theta times cosine theta over cosine of 2 theta, which is cosine of 2 theta is cosine squared. So that would be 25 over 169 minus sine squared, which is 144 over 169. And that's basically, that's going to give us the minus 119 over 169. And the numerator we have 24 times 5, 120 over 169. The 169s would cancel if you invert and multiply, and we get the same answer. The sine of theta over 2 is the square root plus or minus of 1 minus the cosine of phi over 2. And the cosine of phi was 4/5. And do we use the plus or minus? Well, if phi is in the fourth quadrant, because the sign was negative, it was down here, half of phi would still be in the fourth quadrant, and the sign would be still negative. So we're going to use the negative one, not the positive one. and it's 1 minus the cosine of phi, that's 4/5, over 2. So 1 minus 4/5 is 1/5, divided by 2 is 1/10. Square root of 1 over 10, or if you want, that's would have been a fine answer. You could call it minus 1 over the square root of 10, because the square root of 1 is 1. And you could have multiplied, this is fine too, or you could have multiplied by square root of 10, top and the bottom, numerator and denominator, and got minus the square root of 10 over 10. Any of those. Page 2. Cosine minus sine is an example of the cosine of alpha plus beta formula. Says cosine alpha, cosine beta minus sine alpha, sine beta. So this matches up. So if alpha is 92 and beta is 28, this becomes cosine of 120. And 120 is a special angle where the cosine is -1/2. This identity. So tangent of two angles added is the tangent of the first plus the tangent of the second over 1 minus the tangent of the first times the tangent of the second. And pi over 4, the tangent is 1. So we get tangent x plus 1 over 1 minus tangent x times 1, and that looks like that. So we're done. Sine of 2x is 2 sine x cosine x. 1 plus, there's 3 formulas for cosine of 2x. I'll just use the first one. Cosine squared x minus sine squared x. 1 minus, if I put this one with this one, 1 minus sine squared is cosine squared. So I've got 2 sine x cosine x over a cosine squared x, and another one, that's 2 cosine squared x. The 2's cancel. One of these cosines, since these are all multiplied, we can reduce that, cancels one of those, and we get sine x over cosine x, which is tangent x. Sine of 3x. Several people had trouble with this. That's the sine of x plus x plus x, but we know only how to do it for 2 angles, so we do like 2x plus x. That's 3x. The sine of 2 things added is the sine of the first, cosine of the second, plus, if that's plus, a sine, this addition or subtraction stays the same for sine, add cosine of the first, sine of the second. No double x's, so we have to use the double angle formula on that. So that's 2 sine x cosine x times cosine x. Notice we got 2 sine cosine squared. That's starting to look like this. We've got 2 out of the 3 of those. And cosine of 2x is cosine squared x plus sine squared x, and that's all times sine x. So we get, when we distribute, we get a sine x times cosine squared plus a sine 2 sine x times cosine squared. So we got 1, 2, 3 of sine x cosine squared x. And then we've got sine x times sine squared, which is sine to the third x. Whoop. And the cosine is a minus in here, so this turns into minus. Sorry, and now it matches. I messed up my sign there. Last page. A spring is attached to the ceiling, and when an 80-gram mass is put on here, the length is 1 meter, 100 centimeters. So that's balanced right there, stretching the spring to 100 centimeters. Now we're going to pull it down an additional 50, and then it's going to rise above 50 and above and below by 50. So the amplitude is just going to be 50. The distance from the ceiling is 100. So the midline is plus 100. And we're got an amplitude of 50 that's decreasing. It loses 5%, so it's each time it's 95% of what it was. And it loses each second that. So if we make t be the seconds, it's just simply that. So at the beginning, when time is 0, this anything to the 0 power is 1 times 50 is 50 plus 100 makes it 150 down. It's where it's going to be to start with. And then it's going to go up. So it's going and down and up and down. And so we do 2 pi over the period. And it rises and falls twice every second. So to do one wave, it only rise and fall to be back where it's ready to go rise and fall again. That only takes a half second. So the period is a half 0.5 t. Now, 2 pi divided by 0.5 is 4 pi. So if you used 4 pi here, that's also fine. And you don't have to put anything under the t because t was for each second that it lost 5%. So there's the equation. When is it never more than 25? Well, that means the amplitude has to be 25 or less. So 25 or less. So 50 times 0.95 to the t has to be 25, or divided by 50. This has to be 1/2. 25 divided by 50 is 0.5. To solve for power, we do to what power do we raise the base, 0.95, to get an answer of 0.5. And if you type that into your calculator, you get 13.5 seconds. If you can't type that in, you don't have a calculator that allows you to use different bases, you just remember the change of base rule. This is the log of 0.5 in base 10 over the log in base 10 of 0.95. You can divide these and you'll get that. Okay, how far is the mass from the ceiling after 3.2 seconds? So we just got to put 3.2 in for the t. 50 times 0.95 to the t, 3.2, cosine 2 pi over 0.5 or 4 pi times 3.2 plus 100. That works out to be 65.67 centimeters from the ceiling. And that's the test.